electron is a fundamental particle of nature. It is a charge of -1 and a mass almost 2,000 times smaller than a proton. We are told that electrons orbit in a fixed shell or have a pinpoint location. Unfortunately, this is not true. We know that protons and neutrons are located at the center of the atom. So where exactly is the electron? To answer this question, we have to go back to when the Bohr model of the atom was proposed. It predicted that the nucleus was the center and electrons at different energy levels.
Around the same time, de Broglie proposed that electrons acted both like particles and waves. This discovery shattered the Bohr model of the atom, as it depended on the electron being a particle as it orbited the nucleus.
Erwin Schrödinger had a solution. He proposed that electrons are big clouds of probability, in which the atom can be found 90% of the time. The Schrodinger Equation is used to find the mathematical model of this cloud.
To understand this cloud a bit better, let's take a bird's eye view of my house. If we were to ask the question, at 5 p.m, where would I be? Well, if I attached a tracker on myself and put a dot on this map every day at 5 p.m. for a whole year, you can see it formed clumps. Here, I'll be most of the time. Here, very little, and sometimes not even in the house. This represents a probability of finding me at 5 p.m. on any given day. Similarly, for an electron, this represents a 90% probability of finding the electron at any given time.
One bizarre property of the electron is that when you aren't measuring it, it can be represented by this cloud of probability. But when you measure it, it collapses into a point, the electron.
This is shown in Young's double-slit experiment. Electrons are fired individually through two slits and hit a wall. When we measure the interference pattern they make at the wall, it is similar to a wave. Thus, the wave nature of the electron. But if you measure the electron at the two slits and the wall, it forms two lines, as a particle would do.
When you observe it, it's there. When you don't, it's dissolved into this cloud of probability we call orbitals. Here are the ones of hydrogen. Why hydrogen? As it is easier to calculate the behavior of one electron compared to many. This understanding of quantum mechanics helped engineer things from computers to lasers to solar panels to GPS.